Hey, good morning, everyone. Today we're going to work with synthetic division, and this is going to help us divide large polynomials. So we talked about before using long division. Let's give you guys an example of this. It's probably an example that we did before, but x cubed plus 2x squared minus 5x minus 6. And you're like, how do I factor this? If this was a nice x squared plus x minus 6, you could factor this. Two numbers multiplied to become 6 are 1 times 6 and 2 and 3. Which of these subtract out to become 1? We know 2 and 3 does. X, 2 and 3. More positives than negatives, right? We need more positives here. So we need a 3x minus 2x gives us our middle x of what we need, right? Okay, the way we got those are these two and these two. Great, so if it's x squared, we could factor it. But x cubed, unless if it's grouping, and we can check right now, is this grouping? If I take the x squared here with x plus 2, do you see an x plus 2 back here? Nope, and that's one of our cool skills about grouping is that, hey, I might be able to factor x cubed if this was a grouping problem. In this case, it is not. So, thanks, Dad. So what we're going to do here is we're going to use a new type of scale. Well, not really a new type of scale. We're going to use long division. You guys were asked to do long division. So let's go ahead and show you guys, demonstrate this, use long division. And I'm going to give you guys a choice. Do you want to use long division or synthetic division? And almost guarantee you guys will tell me synthetic division. Okay, so here we go. Let's do long division first. When I'm doing long division, I write x cubed plus 2x squared minus 5x minus 6. And I'm going to ask you guys to divide this by x plus 3. All right? X plus 3. So we learned in long division, we say x plus 3. And then we do our 3 steps. We match, we multiply, and then we subtract. These were our 3 steps for long division. Hopefully you guys remember these 3 steps. So we match our x to become x cubed. What can I multiply x by to become x cubed? We need to multiply by x squared. That's our matching step. Check. We multiply this down by our binomial. See, there's 2 terms there. So we multiply it by x squared times x is x cubed. And x squared times 3 is 3x squared. Our last step is we multiply. Now our last step is to subtract. And what I ask you guys to do is to draw parentheses and draw a negative in front. Okay, I ask you guys to draw parentheses and negative in front. If you guys don't show me this step, I'm going to think, are you trying to do this in your head? And if you try to do this in your head, are you going to make a mistake? And if not, maybe you're just copying off something online. So here's what my next step is. I ask you guys to draw the signs inside. Draw a negative and a negative, because a negative times a positive is a negative and negative times a positive is negative. So I better see those negative signs. Now, why do I ask you guys to do this? Because now it's obvious. X cubed minus, see that's a minus, x cubed, that cancels out. 2x squared minus 3x, 2 minus 3 is 1. That's going to be a negative x squared. We follow by bringing down the next term, and we start the whole process over again. We match, multiply, and subtract. So why don't you guys try this next step yourself to see if you guys can get that next step. I'll give you guys about 30 seconds. In a match. What can I multiply x by to become x negative x squared? Hopefully you said a negative x. Go ahead and multiply that down and then draw the parentheses to subtract. Okay, Aaliyah, if you have your own way, that's fine, but just make sure I see the work. It makes sense. Okay. All right, so I'm going to go ahead and multiply by negative x. We multiply down. That gives me a negative x squared minus 3x. Negative x squared minus 3x. We follow that with that was our multiply, and that's do our subtraction step. Now, if you take a look here, I drew a negative in the front. Now I have to make sure I flip it. I do a negative times negative is a positive. That's a positive now, and negative negative is a positive. Let me write that in different colors so you guys can see it. So I make little tiny notations for me so I'm not overthinking. There's not too much stuff going on in my brain. So then that's when I make mistakes. So negative x squared plus, say that's a positive x squared, cancel out. And negative 5 plus 3, negative 5 plus 3 is a negative 2x minus 6. Okay, we're almost done. Let's go ahead and multiply this by what? How can I match x to become negative 2? See, our goal is to match it. I need a negative 2. Match multiply, we multiply it down, so we end up with negative 2x minus 6. Ooh, that looks exactly the same. And when I distribute my negative sign, we do end up with a 0 remainder. Winner, winner, chicken dinner. Now, the problem with long division is we end up writing stuff that we know we're going to cancel. We end up writing stuff. Let me show you what I mean. Don't we write x cubed just to cancel it later? Don't we write x squared just to cancel it later? And don't we write 2x just to cancel it later? So our next method is we're going to get rid of all the fluff. See how we wrote a bunch of x's here? Right, a bunch of x's here? We're actually going to use a new version of this called synthetic division, and we're going to get rid of all the fluff. So let's look at the scheme. I think the best way is to demonstrate how synthetic division works. So synthetic division. And this is a new method for us in Algebra 2 to learn how to divide large order polynomials. Okay? If it was something like this, hey, I could factor that, I could easily work with that. But once it gets bigger, I want to write as little as possible because I want to save time. And this new method saves us a lot of time. So here's a new method. First thing, instead of drawing a division sign, do you know how a division usually goes this way? We're going to spin this around and we're going to draw it upside down. Okay. And the problem we're working with, we said we're going to work x cubed plus 2x squared minus 5x minus 6. And this is what synthetic division does. It takes the front coefficients and just copies these numbers in. We're just going to use these numbers here to set it up. We're going to use a 1x cubed, 2x squared, minus 5x. We don't write the x, we just write the negative 5 and the negative 6. Now what we're doing, we're really writing this step here, except without all the x's. We're just writing this step here without all the x's. Our next move is, I'm going to teach you guys the way I actually have kids write this, is we are going to write what I'm trying to divide by. I'm trying to divide by x plus 3, right? So I write that at the bottom of my L. So if you take a look here, I wrote it at the bottom of my L. The reason why it's going to be helpful later, especially in pre-calculus, that we're going to use this. But the next idea here is I'm going to fill in a number here, right here. What number am I going to write? I'm going to write the number negative 3. How do I get negative 3? You take what you're trying to divide by and make that go to 0. So what number would x be to make that go to 0? That would be a negative 3. Okay, so hang on to that thought. I'm going to just show you another problem. I'm going to make this other problem up. I'll give you another problem. You don't need to copy this, but I just want to help you with the setup, okay? If I write x cubed plus 6x squared plus 11x plus 6, I want to ask you to divide this by x plus 2. Okay, x plus 2. So how would I set this up? In long division, you would have written everything out. X cubed plus 6x squared plus 11x plus 6. And you would write x plus 2 in the front. But if we were working with synthetic division, you would just copy the 1, 6, 11, and 6. 1, 6, 11, and 6. Make sure you have space here. You need space here, okay? It's a 2-row problem. And you would write x plus 2. And we would fill in a negative 2 here. Why negative 2? Because negative 2 is what would make what we're trying to divide by go to 0. Okay, again, where did I get the 1, 6, 11, and 6? I am just copying the front coefficients of my polynomial. These are where the numbers are coming from. So let's go back and double check that one more time. I am trying to divide, my original problem is up here. Try to divide x cubed plus 2x squared minus 5x minus 6 by x plus 3. Instead of writing the whole problem out, I just wrote the numbers in front, which should save me time. The second thing is what I'm trying to divide by, I write it in the front, and I write the 0 right on top of that. Okay. Now here is the process. Get ready for the process. It's very simple. We always add down, and we're going to multiply up. And let me show you what I mean by multiply up. So the first step is always free because there's nothing to add down. We're going to add down, and that becomes a 1. To fill in the next row, here, these values here, we're going to multiply up. Let me go ahead and demonstrate that a couple times, and you guys will see what I'm talking about. To get to my next row, we're going to multiply by negative 3. See how negative 3 is up here? That's my key number. We're going to multiply every step by negative 3 to bring it up to my next step. So what is 1 times negative 3? That's going to be negative 3. Take a look. I'm filling out my second row of numbers. The 1 came down. First one's free. To bring it back up, I multiplied it by negative 3. 1 times negative 3 is negative 3. And again, we're gonna add to come down. What is 2 minus 3? That's negative 1. Okay. We multiply by negative 3. Multiply by negative 3 to go back up. 1 times negative 1 times negative 3 is a positive 3. We add to come back down. That becomes a negative 2. We multiply to go back up. By our key number, it's always going to be multiplying by that key number. That's a positive 6. And the last, negative 6 plus 6 is 0. When we have a 0, that's a 0 remainder. Okay, a 0 remainder. And when you have a 0 remainder, that means you were able to divide it. A quick side example, if I say 12 divided by 4, that's 3 with a remainder of 0. But if I say 12 divided by 5, that is 2 remainder 2. 5 cannot be divided by 12. Well, 12 cannot be divided by 5, other way around. Okay, now here is the next step. I'm going to erase these to make these a little bit prettier. Oops.
Wait,
Okay.
Mr. Cole,
Yes.
I'm a bit confused. What did you get 12 and 4 and 12 and 5?
Oh no, these are just examples of when you divide. When I divide something that works, 12 divided by 4 is 3 with a remainder of 0.
Oh,
But
okay.
12 divided by 5 is 2 with a remainder of 2. And this number here at the end, that's my remainder number.
I see.
So in this case, since there's 0, that means x plus 3 does divide into this huge x cubed plus 2x squared minus 5x minus 6. There's no remainder. Yes, the number in the last spot is always a remainder. Okay. Now, here is our next step. Because synthetic division, as you can see, we interpreted it, right, to get into our method. And now we have to interpret it out to get back to our answer. The answer isn't 1 minus 1 minus 2. What happens was, when we first initially wrote 1, 2, negative 5, and negative 6, these were placeholders. What I mean is, the first spot was a x cubed, 2 was a x squared, 5 was an x, and 6 was a constant. Just like our polynomial, x cubed, x squared, x, and a constant. So each of these spaces on top is actually a placeholder. Now, if I divide x cubed by x, what do we have left? X cubed by x, we have x squared. And this is how we interpret it. This is an x squared, this is an x, and this is a constant. So to rewrite this, we have 1x squared, we have a negative 1x, and we have a minus 2. Please take a look at my answer. It is the same as my long division. Now you might be saying, oh, sorry, go ahead.
So the thing I'm a little confused about is how do you know it's x squared actually?
Okay, Very good. So we start off with a problem as x cubed, and when we divide an x, we drop an x to become x squared.
Okay.
I can show you that in another way real quick, more visual. If I say it's x cubed divided by x squared, blah, 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 blah. Oh, sorry, x, not x squared, just x. Blah, 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 blah. You end up dividing these out, and you end up with an x squared left. Blah, blah, blah.
Okay. All right, thank you.
Okay, of course. Now, a couple things I want you to make note of is that this isn't just made up of fluff, right? This isn't made up of fluff. This isn't just made up someone just say, hey, let's find a pattern and it works. What happens is we are actually doing long division, except with less writing. As I mentioned before, when we do long division, don't we have to repeat stuff over and over and over? And don't we write x, 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 all these x's everywhere? I want to show you what happens with synthetic division. If I take a pot of soup, let's say a gallon of soup, and I just leave it on the stove boiling for like 30 minutes, for an hour, for 2 hours, what happens to that soup? Doesn't it become more concentrated and all the water leaves it? This is actually what's going on. Let me go ahead and show you guys this real quick if you guys haven't seen it already. Remember how we wrote 2 minus 3? Look over here. 2 minus 3. Negative 5 plus 3. Negative 5 plus 3. Negative 6 plus 6. Negative 6 plus 6. What synthetic division is, it's a concentration of long division, and we just took these parts and stacked them together right here. We end up with these stacks here. So it's definitely less writing, for sure. Okay, let me read some of these questions. Where did the negative under the negative 2 come from? Oh, sorry, this wasn't a negative. This is what I'm using for constant. This slot is x squares, this is x, and these are constants. That's what I'm referring to. Okay. We're just dropping in x every single time. All right. So when I divide using long division or synthetic division, what's left over? My answer is going to be the same. Okay. The only thing about synthetic division, you have to reinterpret that answer. All right. Let's look at our next problem here. All right. So we had set this problem up already, and you know what? If you guys haven't copied it yet, go ahead and copy it right now. And on the right side again, set it up. What am I going to write inside here? For x cubed. How many x cubes do we have in the problem? How many x squares do we have in the problem? How many x's and how many constants? So please go ahead and copy that right now. And how many constants? What do I write in this corner here? And how do I fill in my key value? These are things you have to be able to fill out yourself. So we're going to fill out how many x cubed? I have 1x cubed. I have 6x squared. I have 11x, and I have a positive 6. These are all positives here. Signs do matter. 1, 6, 11, 6. I'm divided by x plus 2. So I'm going to write a negative 2 here because I want to make this 0. Right, the goal is to make that 0. So how fast was it? Like, did it take me a long time to fill out synthetic division? No, it definitely was less time than me writing out all the x's here. Okay, we still draw this little bar, right? That's still drawn, except it's just upside down. Okay, so let's go ahead and do synthetic division. We're going to bring it down. First one's free on me. That's a 1. We multiply to go up. 1 times, we always multiply by this key number. We always multiply that by that key number to come back up. 1 times negative 2 is negative 2. 6 minus 2, we're going to combine that down. 6 minus 2 is 4. Let's go back up. 4 times negative 2 is 8. You don't have to draw the arrows, okay? The arrows are just for me to kind of point you to where I'm going. Sorry, that was a negative 8. A big deal with synthetic division, any division problem, we mess up on our signs a lot. Okay, so be careful about that. 11 minus 8 is just positive 3, and 3 times negative 2 is negative 6. Bam, bam, bam. We have 0 remainder. Winner, winner, chicken dinner. So how do I reinterpret this? What does 1, 4, and 3 mean? Mr. Ko, 1, 4, 3 is 8. Remember, these are placeholders. So we went from x cubed, we got rid of an x. Look here, we x cubed, we got rid of an x. So our answer is not x cubed anymore, it's x squared. We have 1 x squared, and then you can just go down the line. That's 1x squared plus positive 4x plus 3. And that is my answer. Now I'm going to do long division here. You guys don't have to copy it, but I wanted to show you guys that everything we did here, we would have done in long division except with more steps. So I'm going to do it quickly. X times x squared is x cubed plus 2x. I draw my parentheses and my negative signs, and I can see 6 minus 2. 6 minus 2, you guys can all see that. 6 minus 2 is 4x squared. Bring down the 11x. I need to match that with a positive 4x. 4x squared plus 8x. I draw my parentheses and my minus sign just so I don't have to overthink. The more I see, the less I have to think. 11 minus 8 is 3x plus 6. X times what is 3x? X times 3. Multiply by 3. 3x plus 6 minus parentheses negative negative. That does give me a 0. Okay.
Mr. Ko, how come the first one you wrote isn't a negative?
To mean right here? Or right here?
Yeah, like underneath where the x cubed.
X cubed is right here? Or right here?
Yeah, that one.
Okay, so remember these
Underneath,
are placed right here. Like, why is that non-negative? Or why is this non-negative?
Mm-hmm.
Okay, so what happens
No,
is,
why is the one?
so I'm trying to figure out which one you're talking about. So the question is, why isn't that negative? Is we do not subtract down, we always add down. So we always go from my first level to my second level by adding. 6 plus negative 2. 11 plus negative 8. 6 plus negative 6. Okay? But my first step, when we first start, there's nothing there. We haven't started the program. So it's actually a 0. There's nothing for me to add. So it's always just bring it down, free on me. Okay, so I'll say free on me. So the first one's always free on me. That's why it's straight bringing down the 1. Okay. If you look at our problem up here, we did the same thing. It was 1x cubed. 1x cubed. That's copied the 1 and we just brought it straight down.
Okay, thank you.
Of course. All right, let's practice this one more time. And here's your problem. It's going to be x cubed minus x squared minus 10x minus 8. I ask you guys to divide this by x minus 4. As you can see, I've been writing division in different ways. I'm flipping it back and forth between the fraction form and writing it as with a division sign, and then back to our fractured form. But all of these mean the same thing. We're doing top divided by the bottom. So please set up in synthetic division. How would you set this problem up? Okay, you're going to fill out numbers here. 1, 2, 3, 4 numbers here. You're going to fill out a factor here and a number here. Once you've done that, make sure you do, you guys can get started on the long division. I'll slowly catch up just to make sure you guys are good. You don't have to write x cubed, x squared, x, and constant once you realize that these are my positions. Okay, those are the positions. We will start with the highest exponent. What if I'm missing a variable? What if it goes from x cubed to x and I lost x squared? You have to put a 0 down. You have to put a 0 down. Tell me if I'm a little laggy. I'm getting an unstable connection. Okay, here we go. Let's hopefully you guys were able to fill it out. This is going to be 3, -1, -10, -8. Double check if you make sure you call those negatives. A big deal is when you forget the negatives, you mess up big. And my term I'm trying to divide by is x minus 4. We write a positive 4 here because a positive 4 is what makes that 0. Remember, the goal is to get a 0 here if possible. No remainder. Whoops, I messed up here. That was a 1. I don't know why I wrote 3. 1. I have 1x cubed. Okay, 1x cubed. Okay, first one's free on me. Since there's no one to add, that's 1. To bring it up, we multiply by 4. -1, -1 plus 4, or 4 minus 1 is 3. Multiply, go up to become 12. You don't have to draw these arrows. Okay, these arrows are just so you guys can see where I'm going. 12 minus 10 is 2. Hey, does it look like we're going to end up with a 0? Does it look like we're going to get there? 2 times 4 is 8. Oh, yes, we are. Bam. X squared plus 3x plus 2. Okay. So we're going to do this one more time now, and we're going to race. We're going to race. Now, here's one thing. If you do not write it back in your polynomial form, it is wrong because you didn't complete the synthetic division. Synthetic division is just a tool, but we always have to reinterpret it. Okay, go ahead, Eden.
Do we not have to make them negative because in the first... Oh, never mind. I see.
Okay, so they were negative when we first copied it from here to here, right? They were negative, but once I combined them, they were actually all positives here. Okay, let me give you another one. Okay, so here's my problem, and we're going to race. I'm going to do long division, you're going to do synthetic division, and once you're done, type anything on the keyboard and just hit enter, because I just want to know that you finished. You don't have to tell me the answer, you just have to type blah 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 in the chat so I know you're done. Okay, to see if you beat me, and we'll see who's the fastest. And I can almost guarantee you all you guys will beat me. Okay, but I'm gonna burn rubber. So here's my new one. It's going to be x cubed minus 7x squared plus 2x plus 40. And we're going to divide this by x minus 4. Don't start yet, okay? Don't start yet. No one start yet. I'm going to let you do right now, I'm going to let you set it up. Actually, you know what? Just draw this. You draw this. I'm going to draw this. Okay? So you are going to copy down. Actually, you know what? Let's copy down right now. You guys can go set it up. Go ahead and write down the numbers that you would put here. And I'm going to write the numbers. You guys write the numbers, fill out this. I'm going to fill out this. But do not do the rest of it. Just fill it out. I'm going to write x cubed minus 2x squared. Oh, 7x squared. Oops. Plus 2x plus 40. And then I'm going to write x minus 4. For you guys, make sure you guys wrote 1, -7, 2, and 40, right? These are my placeholders. That's x cubed, x squared, x and a constant. Just double check we didn't miss any numbers. And you're going to write at x minus 4. And to make that go to 0, you're going to write a 4 on top. Okay? All right. I'm going to give you guys a count of 3. 3, 2, 1, go. Okay. Don't start yet. And I'm going to race you. I want to see who can get the answer first. Once you're done, go ahead and type anything in the chat and hit enter. It could be whatever. Just spam it, whatever. Don't spam too much. Just type it once, and I can figure out who finished. Any questions?
Wait,
Yes?
we're going to do the synthetic division?
Wait, what?
We're going to do the synthetic division?
Yeah, you guys do synthetic. I'm going to do long division. And the goal is to prove that this is way faster. Okay? And that you guys can do this pretty quickly. So once you guys are done, just type anything in the chat. So I know you guys are done. But I'm probably not going to see it because I'm going to be trying way too fast to try to beat you. Okay. Okay. In 3, 2, 1, go. X squared, x cubed minus 4x squared, parentheses, negative positive, -7 minus -3, x squared plus 2x, -3, x, -3x squared plus 12x, parentheses, negative, positive, negative, negative 10x. I need negative 10 plus 40 multiply negative 10x minus, so plus 40. All right. So I finished probably about a minute. Oh my goodness. Michael even had time to write in the answer. Okay, well done, folks. So most of you guys hopefully feel like this was faster. Okay, and just to double check, first one's free on me. That's 1, 4, negative 3, negative 12, negative 10, negative 40, 0. Reinterpret x squared minus 3x minus 10. Great job. Okay, so literally it took me like 30 seconds to do this. Okay, maybe another 10 seconds to set it up, but I would have done setup here also, but it would take me longer to write the setup problem. So hopefully you guys are believers that synthetic division works. Now again, why does it work? Is because we took away all the fluff. I don't write x squared, so I'm going to show you guys in red here the stuff that I got rid of. Once again, I got rid of the x cubes. I don't write x cubes. I just wrote 1. I don't write x squared. I don't write x squared. I don't write any of these x's. I don't write any of the variables. I know that the 3 and the minus 3 cancel out. I know that the 10 minus 10 cancel out. I don't write any of that stuff. So what am I left with? I'm left with, in the blue, 7 plus 4. Bam, 7 plus 4. I'm left with 2 minus 1, or 2 minus 12. That's 2 minus 12. I'm left with 40 minus 40. 40 minus 40. Right? It's really just the pure part of this long division. Now we have one more thing to talk about here, is what if there is a remainder? What if there is a remainder? So let me give you guys a problem. Actually, you know what? Let me give you, let's do this. X cubed minus 5x squared plus 4x minus 3. And we're going to divide this by x minus 1. Okay. Let's do this with a synthetic division. This will be 1, negative 5, 4, negative 3. We're going to write x minus 1. And to make this go to 0, remember that's going to be a positive 1. Once you guys go ahead and spend the next 10 seconds solving this, and you'll notice that there should be a remainder. If I thoroughly screw this up correctly, there should be a remainder. One times 0 is 0. We're going to end up with negative 3 as my remainder. Now, to reinterpret this, we started from x cubed. Now this is an x squared value, right? So we have to write this as x squared. So to reinterpret this, this becomes 1x squared minus 4x plus 0. So I don't need to write a 0 here. Okay, so that's a plus 0. So I don't need to write a 0. Remember, these numbers here are placeholders. So I have 1x squared, I have 4x's, and I have 0 constants. So please be aware of that. And how do I write the remainder? We write negative 3 over x minus 1. Why do we write it this way? Because didn't we try to divide out an x minus 1? We did. And we couldn't do it. So we still have 3 out of x minus 1. We actually do this with regular numbers. If I say again 12 divided by 5, 12 goes into 5 2 times plus a remainder of 2 out of 5, as we write 2 2/5. And what we do is, take a look here, we write what we try to divide by as our fraction at the end. So what we're trying to divide by, that's our fraction at the end. Okay. Let's give you guys another problem. If I say x cubed minus 4x plus 1 divided by x minus 1. Okay, so take a look at this next problem. This is a side note here. Set up synthetic division. Now careful, I am missing a variable. I go from x cubed to x. I am missing a variable. So we're going to write, I have 1x cubed, I have 0x squared, negative 4x's, and a 1 constant. if you take a look here, I don't have any x squared. That's why we have to put a 0. Because these are placeholders. And we're trying to divide by x minus 1. That's a positive 1. Let's go ahead and do it. 1, 1, 1, 1, negative 3, negative 3, negative 2. And I always draw that last number in the box. Okay, let's make sure you guys are cool with this. First one's free on me. 1 times 1 is 1. 0 minus 1, sorry, 0 plus 1 is 1. 1 times 1 is back to 1. Negative 4 plus 1 is negative 3. Multiplied by 1 is negative 3. And then 1 minus 3 is negative 2. Rewriting this, we went from x cubed to x squared plus x minus 3 minus 2 over what I had to try to divide by, x minus 1. And that is synthetic division, folks.